Hello everyone and good morning. Today I'm going to present about electrical drive for gantry crane system for the subject BTE 4763 drive and actuators. My fellow presenters are one Izzryn Irfan bin one Ishlah and number two is Muhamad Ikhsyam bin Mazlan and number three myself Kelvin. So first we will see an introduction about a gantry crane. So a gantry crane stands as a towering symbol of industrial efficiency, combining robust engineering with unparalleled lifting capabilities. This versatile lifting apparatus often found in shipyards, construction sites, and manufacturing facilities, and it is characterized by its overhead gantry structure supported by legs on either side. The distinguishing feature of a gantry crane lies in its ability to traverse horizontally along rails, facilitating the seamless movement of heavy loads with precision and power. So as we can see here, gantry crane comes in various configurations from single girder gantry crane, designed suitable for lighter loads, to double guided semi-gantry crane that capable of handling massive weights. And these cranes plays a pivot role in streamlining material handling and process, offering a reliable and a safe solution for lifting and transporting goods across expensive work areas. So in this presentation, we will focus portable gantry crane type in this presentation because its simulation is very easy for us to do. So a small general background for gantry crane. So as we can see, the structure typically comprises a horizontal bridge supported by upright legs, finding application in diverse industries such as shipping, manufacturing, and logistics. So for this system, there is an electrical drive system that is crucial component that enable efficient and precise control of the crane's movements. So there are two type of gantry gates, which is rubber tire gantry crane (RTG) and rail mounted gantry crane (RMG). RTG, which is rubber tire gantry crane, are mobile and move on rubber tires. They are commonly used in container yards, and RMG, which is rail mounted gantry crane. This crane can travel on fixed rails and are often used in container terminals and industrial facilities. So the basic component of electrical drive system is gantry cranes are typically powered by electric motors. So common type include AC induction motor or more recently synchronous and asynchronous motors. So to control the electric motors, there will be motor controllers which will regulate the speed, torque and the direction of the motors. So VFDs, which is variable frequency drive, are commonly used for this purpose. Third is power supply. Power supply will be usually connected to electrical power supply and the power is distributed to various components through a control system in a gantry system. PLC, which is Programmable Logic Controller, is used to control the overall operation of the gantry crane. It receives input signals from various sensors and translates them into commands for the motor controllers. Fourth is HMI, Human Machine Interface, an interface that allows operators to monitor and control the crane. It may include a touchscreen display and control buttons. The modern gantry cranes will be in touchscreen display, which the old ones all will be in a control buttons. So there will be limit switch for safety purpose that defining the travel limits of the crane and for prevent collisions. Emergency stop system is crucial for the system that which can quickly stop crane movement in case of an emergency. Overload protection. prevents the crane from lifting loads beyond its capacity or act as a safety protection for motors. Regenerative braking. Some modern gantry cranes incorporate regenerative braking system which recover and reuse energy during braking operation, improving overall energy efficiency. So design of electrical drive system for a gantry crane depends on a various factors, including the crane type, load capacity, operational environment, and specific application requirements. So next is methodology. So methodology is more about self-developed and implemented a gantry crane drive simulation using software called Proteus, showcasing our proficiency in control system, design and simulation. So in this simulation, the driving circuit simulation includes motors, act as AC induction or synchronous motor, relays as a contactors, buttons and power supply. The system general operation is managed by relay, which act as a control component. When any button is pressed, the relay is energized and the motor will rotate. As you can see on your right of the slide, there will be a flow chart for the developed system. So as we can see the flow chart, if up button is pressed, the motor 1 forward and motor 2 reverse. Up and down button are used for the voice control for carrying the object. The left and right button is for the motor run and for moving the gantry crane left or right. Motor 5 and 6 is for forward and reverse gantry crane movement.
Hi, Assalamualaikum. My name is Ikhsyam Mazlan. I will present about result and discussion for assignment for GANTRY crane. The simulation was simulated in Proteus, consist of 6 buttons, which is up button, down button, left button, right button, and forward reverse button. When up button is triggered, motor 1 forward, motor 2 reverse, resulting hoist to pull the load up. When down button triggered, motor 1 reverse, motor 2 forward, resulting the crane to lowering the load down. Left and right button triggered when want to move the load to left and right, and forward reverse button used to move crane forward and backward. Discussion for this simulation is safety features are needed, such as emergency stop button to immediately have for all operation in case of accident, and ultrasonic sensor to detect nearby movement or obstacle during lifting to prevent accident. Why safety features matters? Because lack of safety features compromise simulation accuracy. Emergency stop ensure quick response to accident, and ultrasonic sensor prevent mishap by detecting nearby obstacle or people. Benefit of safety addition is to enhance simulation reliability, mimic real-world safety measures for practical gantry crane application.
Conclusion. In conclusion, the design of the gantry crane simulation using Proteus software demonstrates a functional representation of the control system for a crane with 6 motors and relays, controlled by corresponding buttons for various movement. The simulation successfully replicates the basic functionalities of a gantry crane, including lifting up and down, left and right movement, and forward and reverse motion. However, the simulation has identified areas for improvement that enhance intuitionism and safety features. One major concern is the absence of safety features, which is a critical aspect of any industrial application, especially for heavy machinery like cranes. To address this, the inclusion of an emergency stop button is recommended. This feature would provide a quick and efficient means to halt all operation in case of an emergency or accident, ensuring the safety of both personnel and the equipment. Moreover, the design could benefit the integration of sensor, such as ultrasonic sensor, to detect the presence of obstacle or individuals near the gantry crane during lifting of operation. This additional safety measure can help prevent accident by providing real-time feedback about the surrounding, ensuring the crane operates in a safety environment. That's all from us. Thank you.